Today we talk about the experiment investigate the principle of superposition of two concurrent forces, and we had know the theory of the experiment has been already learned in high school. This is the representation of the force in the diagonal of the parallelogram with two sides representing to the component force. We use experiment to determine the relationship between the force of two concurrent force and two concurrent force. To teach this clearly, the question to the teacher need to put in mind is what is the relationship between the two forces of concurrency and their synergy. With the problem, how do you students come up with the problem naturally? Naturally, we create the following situation. Let two boards pull the bar in two directions, while the bar go in the middle. When the first board pulls up the traction, the bar moves in the direction of the board, the stronger the force, and vice versa. You can see that picture. This picture.
I have a question.
Yes.
What is the purpose of presentation of the problem set?
Oh, thank you for the question. The purpose of presentation of the problem set is create excitement for the student, have student focus on problem and solving the solution in order to representation by natural way. Okay, to solve about problem, we will have to use the experiment so that two concurrent forces can be found. Their force and must be able to demonstrate the force visually. From there it is possible to study the relationship between two forces of conversion and their union. Okay. To implement the above solution, we use the following experimental setup. The object acts on by two concurrent forces is spring attack to the magnet on the iron board. This spring. Okay, the two forces that are in the middle of the force to tension of the two string attack on the two dynamometer. This is dynamometer with 5 Newton. To represent these two forces, we use a pen drawing up to immerse with the direction up to y. The direction of dynamometer. The point in note. The magnitude measured by a ratio 1.5 Newton, respectively 1 centimeter. We express two concurrent forces F2 row in the board. This node and F1, F2, then stop. Then stop. Affect two concurrent force. Only affect a single force. So that is effect on the same effect of two concurrent force. So we perform this part In the same way, we get the third. We get the third around F. Remove the force and remove the dynamometer and the object from the boat. We get 3 around 1, 2, and vector F1, F2, and F. We check the relationship between the three forces by ratio m 0.5 Newton, respectively 1 centimeter. Okay, now that is the implement of solution. After that, if students have not made prediction, we link the dotted line between the ends of around S. So hopefully students will predict these 3 representation of the diagonal and the two sides of the picture. If students have predicted, then the experiment to test again. Then we check the length of 2 pairs of opposing sides are equal. If they are equal, it means F equal to F1 plus F2 consider x e that it means that's equal to x plus e, same thing. So if they are equal, then it's still the parallelogram rules. Finally, conclusion. From the result of this experiment, we can conclude that the main clothes is the representation of the force is a diagonal of the parallelogram with 2 sides representing the 2 component forces.